to this video on factoring a difference of two squares. By the end of this video, you should be able to rewrite special case two-term quadratic expressions as a difference of two squares. Alright, so we're going to start today with a little bit of review. Take a moment and I want you to pause the video and go ahead and answer these three questions. Remember, we're going to distribute, so x times x, x times 4, negative 4 times x, and negative 4 times 4, simplify them down, and then come back once you've finished. So in each of these cases, when you distributed, you ended up having these middle two terms cancel out. So each of our answers ended up being two terms. And so what's happened is, if you notice, look at each of the parentheses, they're identical except one of the parentheses has a minus and one of the parentheses has a plus. The two parentheses are identical except one of the parentheses has a minus and one of the parentheses has a plus. Okay, so that's opposite signs like that cause these two middle terms to cancel out. And the resulting is you have a perfect square minus a perfect square. This is a perfect square minus a perfect square. Our last one is a perfect square minus a perfect square. So this is called a difference of squares. Difference meaning we're subtracting. So it's a binomial is considered to be a perfect square if both terms in the binomial are perfect squares. So the first term squared minus the second term squared. Before we can do these, we should always check for GCF. Okay. So what we're going to be looking for is, I'm going to show you a couple ways to do this. The square root of the first term and what is the square root of the second term. And then your pattern overall will always be one of the parentheses will be positive and one of the parentheses will be negative. Okay, so let's just take a look. We're going to do this the way we've done it, and then I can show you another way. So when we only have two terms. We have A is 1, and negative 4 is actually C. That's because our B term is 0 because it canceled out. It's not there. So when we do our A times C, we're going to get a negative 4. And remember, anytime you get a negative value, that means the signs of your factor pair are opposite of each other. The factor pairs for 4 are 1 and 4 and 2 and 2. Which of those would add together to give me the 0? This pair, if I have a positive 2 and a negative 2, so if I substitute them in, x squared plus 2x minus 2x minus 4. Okay, so that's what we've been doing. And we can split this right down the center. On the left, these two have an x in common, so I take the x out and I'm left with x plus 2. On the right, these guys have a negative 2 in common, so I take out a negative 2 and I'm left with x plus 2. So when I write it all together in its final factored form, I have a positive 2 and I have a negative 2. Okay, so that's that pattern that we were talking about right here, that you're going to have the same numbers in each one, but one will be positive and one will be negative. The order in which the positive and negatives go does not make a difference. So we'll try it again here. There's no bx term, so that means your b is 0. When I multiply a times c, I get negative 36, which means my factor pair signs were positive and negative, which we knew it was going to have to be to get these to cancel out in the center. So for 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Those are all our factor pairs. So which pair with opposite signs will add to 0? It will be this 6 times 6. Okay? So we're going to substitute them in for b squared minus 6x plus 6x minus 9. Now we can do grouping like we've been doing. On the left, these should be b's, sorry. Okay. There's a 2 and a b in common. So our GCF will be 2b. And we'll be left with a 2b behind And then minus 6b will be minus 3. On this side, we're going to have a 3 in common. We'll have 2b minus 3. So my final factored form would be 2b minus 3 times 2b plus 3. So that's one way. The grouping, making 4 terms and grouping always works. We can shortcut this just a little bit. So what we're saying up here is what is the square root of the first term and the square root of the second term. So really what you're looking for, what times itself will give me 9x squared. So if I take 3x times 3x, that gives me 9x squared. 1 would be 1 times 1. It's a perfect square. So if I follow the pattern, the first term and the second term, one with a plus and one with a minus. So from here, I can write my 2 parentheses. I'm going to put a 3x in each of these and a 1 in each of these. And I'm going to make one of them positive and one of them negative. And that can be our final answer. This only works for a difference of squares. Okay? So let's try it here. We're going to go the long way and see what happens. So b equals 0. So we are looking for a times c. Well, first, do they have anything in common? 16 and 25, 1 would be the only thing they have common. So we've got to multiply 16 times 25, which is 400. That's a pretty big number. So I'm looking for opposites. So 1 and 400, 2 and 200. So let's pause the video and get all of our factors and come back. Alright, so here we have all our factors. 400 is a big number, so it has a lot of factors. I need to get to 0. Well, 20 minus 20 would give me 0, but let's be very cautious here. 16 times 25 was positive 400, which means the signs of my factor pair were either both positive or both negative. I cannot have a positive or a negative to make these two cancel out to 0. So you'll notice the name of what we're doing is called the difference of squares, meaning subtraction. This is not subtracting. It's adding. You cannot find a difference of squares. This will never factor out. So this is, if you can do nothing to it, this is what we call prime. We cannot factor that. If you can't even take out a GCF, it's called prime. Alright, so let's try some more. Sometimes we do have a GCF, so we should always be checking for GCF first. So we do have a 2 here, and that will leave us x squared minus 4. And this is a perfect square, and this is a perfect square, and they are subtracting. So this would be x times x. 4 is 2 times 2. Okay. Now we're going to write our final answer here. Bring your GCF down like we did before. We cannot lose that. We're going to have 2 parentheses. One's going to be positive, one's going to be negative. The order once you put those does not matter. And you're going to take these and distribute them evenly between the 2 parentheses. We have 2 x's and we have 2 2's. And if I multiply all of this back, I'm going to end up right back where I started from. So we're going to check for GCF first. Let's go on to number 2 in this section. 36 and 100. The biggest number they have in common is 4. But notice both terms also have an m. So we're going to take out a 4m. Write it out front. What will be left over is 25m squared minus 9. So first I got to see if I can go on any further. I got subtraction between them, so I know I'm okay there. So I have to determine, are these actually both squares? Well, we know 9 is. That's 3 times 3. 25 is 5 times 5, but there's an m squared, so really this is 5m times 5m. Okay, following our pattern, we know one of these will be positive and one will be negative. It doesn't matter which one's which. We have two 5m's. Put one in each parenthesis. And notice it's what comes first, so I always put it first in these parentheses. And the other number we have two of is 3. And that will be our final factored form. We can do this, or we can do what we've been doing. They will give you the same answer. It doesn't matter which form you do. Let's try this one. 24 and 54 have a 6 in common. Our GCF is 6. And what's left over is 4c squared minus 9. We've got a GCF of 6. Now let's make sure are these both perfect squares. 4 definitely is, and c squared definitely is. So that'd be 2c times 2c, and 9 is 3 times 3. Okay, so we're going to take those and we're going to distribute them in the two parentheses, make one positive, one negative. They have to be in the same order. 2 c's came first, and then the 3's. Okay? And we'll do this one the long way just so you can see it's still the same thing. It doesn't matter. 80 and 125, well, I can see they got two x's in common right off. So I know we've got x squared in common. And the largest number that they have in common is actually a 5. So our GCF here is 5x squared. And what will be left is 16 minus 25x squared. Well, these are really big numbers. So this is where we might not want to do this longer method with these really big numbers. So we're going to look for our pattern to see if it works. We have 16. Well, that's 4 times 4. We have a minus sign, so we're okay there. 5 and the 25x squared is 5x times 5x. Now notice this is written backwards. Usually the variable comes first. That's okay. We still are going to, when we distribute these between our parentheses, the 4's are going to come first and then the 5x's. So our GCF was 5x squared. And then we have two 4's, and they come first in the parenthesis. And then we have two 5's, x's. They come second. Make one positive, one negative. And this, if we multiplied it all the way back together, will take us right back to where we started. Hopefully that was helpful. Let me know if you have any questions. See you in class.